Hi, in this short video we're going to look at how we can make some modifications to the Waltz schema and how that flows through the code base. Okay, so let's use a real example. So I've got an issue that I want to work on today. It's about doing some improvements to the home page. It's about creating a favorites thing. So the actual change itself isn't that important, it's the process that we're going to be focusing on. So you see we've got a issue here for 876. So we'll create a new branch. We'll switch to that branch. It's going to be in here. It's already on that branch. Just knock it out of presentation mode for a second. You can see we're already on that branch. So we're going to talk you through basically how to make simple schema modifications using Liquibase. How to apply those to a schema, how to roll it back, and how the code can then be generated and updates to data objects, DAOs, etc. So within Waltz, all of the database changes are stored within the Liquibase changelog files. These are in the Waltz data DDL Liquibase directory. And you'll see there's a whole bunch of them, practically one for every version. They are controlled by the master file, which lists them all out in the order that they need to be applied. So when you come to write, if you're the first person making a change for a new version, you need to start a new file and include it. We also have a properties file. This is effectively a sort of data dictionary. So we define up front what some of the types mean. More useful typically when we get into this. So we're saying, look, if we've got an asset code, and that's how it should be declared. So when you see in the actual Liquibase files, you'll see references to these types, and it gives us a degree of database independence as well, as we can map some of these to different meanings in different databases, or different representations, I should say, in different databases. So let's crack on with the change. So I've got a file here. This is the latest as of now, the 126. You can see it starts off, this is a new thing that we're putting in as a tag, which means that basically if we roll back to this tag, then it'll undo all of these changes. Actually, there's an existing change for an empty alias, and we can see this is the change I'm working on at the moment. Won't go through exactly what Liquibase is. Hopefully you know that already, or you can read about that quite easily. So this is basically adding a column to this table, another column, provenance is read only, and then we're going to add to the same two columns is read only and provenance to the application group OU entry, as well as the application group entry. So we have a quick look. Oops, don't want that there. Let's just get rid of that for a second. And that. This is the sort of tables that we're really interested in: the application group, the members, and the entries. In particular, these two. We want to add provenance and is read only to these. So, if we run that Liquibase, actually before we do that, let's just talk a little bit more about some of that. We may have noticed that the naming convention here is described in that readme file that we were looking at earlier. But it's the date of the change, the issue number, and then effectively the change set number. So quite often if it's a complicated change, it might be split across 3 or 4 different steps in change sets. Obviously those should tie back to the issue number on GitHub. So let's go about making this change. So down here there's a couple of ways you can apply these changes. One is use Liquibase directly, another is to use the Maven. This time we'll quickly go through the Liquibase way of doing things. So I've got a script here, just knocked up, which basically runs Liquibase using the Postgres driver. It comes from this jar. This is where we're getting the changelog from. So again, that's a link back to that changelog master we talked about before, which listed all of the individual changelogs, the connection string and some credentials, and then whatever else is passed as a parameter. So if we run this Liquibase, liquid base per, and we'll run migrate, which is the default. We should see that kick in and realize for the version of the database that it's got a few steps it needs to do, and that should have done them. So if we switch to this, refresh the tables, and then have a look at that diagram again, we see, there we go, it's kind of redrawn it a bit, but we've got the is read only in the provenance and the is read only in the provenance. Just to show there's no magic there, we can do a rollback. This will ask me what you're wanting to roll back to, and we can use the tag name that was provided at the top of this file, v1.25 v1.25. Whoa, clunk clunk, and there we go. See, it's rolled back those changes. So we can now see, if we refresh again, go back to that database schema picture. Yep, those two have disappeared. Okay, the other way I mentioned of doing this is via Maven. So let's have a look at the Maven way of doing it. Let's bring up the Maven Profiles. So, as discussed in another video, the Maven Profiles. So we've got Waltz Postgres, which is standard Postgres drivers, a pointer to my local instance of Postgres. So that's the basic driver information, and that's the actual instance kind of information. So to do this, we can run various different targets, but the easiest one is probably just to tell it to do a clean compile, and that will run off and start doing all the changes, rebuilding Waltz. But during one of the steps, I think it's Waltz Schema, it will automatically run the liquid base Maven plugin and do that migration for us. And there it is there. It's doing the liquid base change now. That should be done any second. There it goes. Refresh this now. We should see that change straight away. Okay, there we go. We can see it. This is still currently building the rest of it. What will be happening now is that Duke will have started generating the code, so that within Waltz, we should start seeing the app group entry. We can now see these are the DAOs that access these tables. So in here we should see, if we start doing completion in here, application.entry, I'm just going to choose this randomly. We've now got the is read only and the provenance, so we can then start plugging those into these mappers, etc. And we can into the queries, the Duke queries, and fix up the code, and that's pretty much everything. Once you're happy, commit any appropriate unit tests or integration tests, and send it for review. Okay, thank you very much.